Hey everyone, welcome to DSA with Jis. Today we're going to solve this Leetcode problem, serialize and deserialize binary tree. So serialization is the process of converting a data structure or an object into a sequence of bits that can be stored in a file or memory. So in this problem, you are given a binary tree and you have to write two functions that will convert this binary tree or serialize this binary tree into a string, and another function that will take that string as an argument and convert it back to its original form, which is this binary tree. So in simple words, you need to represent this binary tree into a string, and then you have to convert that string into a binary tree. And the algorithm for serializing and deserializing are not restricted. You can use whatever algorithm you want. There's a restriction as mentioned in this line. So it works pretty much similarly how you store the passwords in databases. So when users create their account, you don't store their password as it is on the database. First, you take the password, you hash it with a hashing algorithm, then you store the hashed password. And when the user tries to log in with his password, you convert that hashed password into the normal password, and then you let the user sign in. So how we are going to solve this problem? So there are many different ways we can solve this problem. The easiest solution, in my opinion, is using depth first search, or more specifically, depth first search in pre-order traversal. So in pre-order traversal, you print the parent node first, then you visit the left node and the right node. So first we will create a string, then we will start doing DFS, depth first search. First we will visit the root node, the value has 1, so we will add that to our string, so 1. Then we will go to the left node, which is 2, so we will add 2 here. Now you need to use a separator to separate the values, so I'm going to use a comma. So from 2, we have to visit its left node, but its left is null, so we can add n here. N means null, but you can put whatever you want here. You can also put the word null. Then on the right side, we also have null, so I can add n again. So the left side is fully visited. Now we can go to the right side. So we can add node 3. Then we'll go to the left side. Now the value is 4. We can add 4 here. Again, we have null nodes left and right. So n and n. Then we will go to the right side of the node. So we have 5. And again, it's a leaf node. So we're going to put n and again null. So that is our serialized string. The time complexity of this is going to be just O of n, because we have to traverse every single node. And now we need to deserialize this string and convert it back to this original form. So let's see how to do that. For this, we are still going to use depth first search or depth first search with pre-order traversal, because we have to reverse engineer it. So we will loop over every single item of this string. We will add a pointer. So a pointer will point to the first value, which is 1. So we can put 1 as our root node. Then we have to go to the left node because we are doing DFS. So we can go to the left and put 2 here because the value was 2. Now we can shift a pointer to this node. So n means null. So the left side is null. Then we shift a pointer again. Right side is also null. So this is our leaf node. So we are done with the left side. Now we can go to the right side. Pointer should point to 3. So we will add 3. Now our pointer is on 4. So we have to go to the left side. So it will go to the left side. So 4. Now again we have null and null, which means that the left side of the node and the right side of the node is going to be null. This is a leaf node. Then we can go to the right side of this node 3, and the pointer should point to 5. So we're going to put 5 here. And then null and again null. So this means it's a leaf node. So we have successfully converted our string to the binary tree again. So these two are exactly the same binary trees. Deserializing is going to be also often because we have to loop over every single value of this string. So let's just write the solution. So let's first create two variables. So const splitter, it's going to be a comma, then const null for storing the value n, and let's write the serialize function. I'm going to create an output variable, which is an empty string. Let's create a DFS function. It will take a node as a parameter. Let's call the DFS function and pass the root node, and we will return the output variable. So first we need to check the base case. What if the node is null? It could be that we have passed the leaf node, or it could be the root node is null. If the node is null, we will return null. We can add null to our output variable. So output, I will concat the string. So it would be the null variable that I have created earlier plus the splitter. If the node is not null, we will again concat the string. So output, it will be our node dot value plus the splitter. And once we are done adding the value to the output, we need to traverse to the left side and the right side. So I will recursively call the DFS function and pass the left node and call again and passing the right node. So after we are done with traversing the entire tree, we will return the output. Now let's write the deserialize function. Now the data, which will be a string, will have comma as a separator. So we need to split the string and convert that string to an array. So const vals would be data dot split, and we need to pass comma. And one base case would be that whenever we will add our values, the output will have a extra comma at the end. So for example, if the output string was 1, then comma, then 2, comma. So this extra comma is totally unnecessary, which will give us an empty string in our vals array. So you need to remove the last item from the array using the pop method. So vals.pop. Now we can create a pointer. So let pointer would be 0. Let's create the DFS function again. So this DFS function won't actually take any argument. So it could be the case that our pointer's value is greater than the length of this val string. In that case, we have to return. So if pointer is more than or equals to the vals.length, then we're going to return null. We can get the current value, so const current value, which will be vals pointer. So it could be the case that our current value is null or simply the character n. We need to return from there. So if current value is equals to null, then we're going to return null. But we need to also increment our pointer. And if the value is not null, we need to create a new node so that we can add it to our tree. So let new node is going to be new. We need to use this tree node class. And we need to call the number method to convert the string to a number because the current value is going to be a string. So let's pass current value. After that, we can increment our pointer. So once we have a new node, we need to get our left node and the right node. And we're going to get that by calling this DFS method recursively. So new node dot left will be traverse. So in a traverse, it's DFS. And same thing over here. And it's going to be right. And we have to return our new node. Now returning this new node, from this recursive call, we'll set the left node and the right node. And once the left node and the right node is set, we will again return the node. And this is how we will construct our tree. And once we are done with all the recursive function, this DFS function will also return you a node or null. So we need to call the DFS method. So that should be it. It should solve the problem. So let's run the code. Okay, so our solution is accepted. Let's submit. Hopefully it will pass all the cases. Okay, so our solution is accepted for all the cases. So that's it for today's video. If the video has been helpful for you, don't forget to like, share, and subscribe to my channel. And I'll see you in the next one. Goodbye.